So here I am back. I'm just going to plug these numbers into the calculator. I hope you're doing them along with me. If I make screw-ups, just like in class, please shout them out to me through email or Schoology, and I'll fix it. But anyway, so we've got 1.8 times 10 to the negative 5 times 0.5. And we're going to square root that value. Now remember, on the AP exam, you are not going to have calculators, and so on every problem. And so having cut that in half, notice this works out. I don't know how well you can see that on camera. It looks like not at all, but we'll see. We end up with 9 times 10 to the negative 6. That is something you definitely should be able to take the square root of. Square root of 9 is 3. The square root of 10 to the negative 6 is 10 to the negative 3. So even without a calculator, although I'll still plug that in, so even without a calculator, notice we can do that math, and we end up with x, which is representing the H concentration, equals 3.00 times 10 to the negative 3 molar. So now I know, remember, we don't have calculators on the multiple choice. So where there's a multiple choice problem involving this kind of thing, we know the pH is going to be approximately 3, but this coefficient is greater than 1, so we know it's going to be just less than 3. So we know the pH is going to be 2 point something. Now to figure out what it exactly is, I'm going to actually negative log it on the calculator. And we get 2.5, what is that, 23. I think I read that right. So make sure you're able to do something along those lines. Now, obviously, the pH is going to go up when we start adding sodium hydroxide. Now, notice, again, the molarity of the sodium hydroxide is the same as the acid. The volume of our acid is 30 mils. The volume of sodium hydroxide at this particular point in time would be 15 mils. So in other words, don't we know we're at the half equivalence point? In fact, I'm going to point this out to you. Here's our acid. I'm going to ignore the sodium. It'll be a spectator ion. If you got questions about that, please ask. Anion plus water. The initial amount of millimoles, 0.5 is half. Half times 30 is 15. Same deal with the sodium hydroxide. The sodium hydroxide concentration is 0.5. This is 15 mils. Half of 15 is 7.5. Well, look at this numerical relationship. It's 15 to 7.5. Isn't that a 2 to 1 ratio? So this would be 0, this would be 0. Just take note of that. This will change by 7.5. This will change by 7.5. This will go up by 7.5. Who cares about water? And so at the end, don't we have 7.5 millimoles of the weak acid? Don't we have no base left over? Don't we have 7.5 millimoles of the anion? Now remember what a buffer is. A buffer is a weak acid mixed with its conjugate base. Isn't that exactly what we've got? Here's conjugate base. Here's weak acid. So don't we have buffer? And so being that we've got buffer, by all means, we can use the Henderson-Hasselbalch equation, which says the pH equals the pKa plus the log of the anion over the acid. Well, we've pointed this out multiple times in all the problems we've done to this point. 7.5 over 7.5, doesn't that become 1? And the log of 1 equals 0. So don't we have this term equals 0? And so don't we simply have to take the negative log of 1.8 times 10 to the negative 5, because that is our Ka value given in the original part of the problem. And so we negative log that, and this is one I happen to have memorized because I've done the negative log of acetic acid's Ka, I don't know how many thousands times, but it's 4.745 if you negative log that. This, I hope you remember, I just pointed it out a moment ago. On the titration curve, I pointed out the equivalence point is when we've got the same number of moles of acid and base. I pointed out the half equivalence point. It's when we've neutralized half of our acid. Isn't 7.5 half of 15? So haven't we neutralized half of our acid? So therefore, we're talking the half equivalence point. Why does the half equivalence point matter? Because at the half equivalence point, the pH will always equal the pKa of the acid. So quite frankly, the minute I realized that this was 15 mils, half of 30, both are 0.5 molar, I really did not need any of that, and nor would you. So the minute you recognize, wow, I've got a weak acid, I'm going to make buffer. This particular mixture brings me to the half equivalence point. At the half equivalence point, you'll have the log of 1, which is 0, which means the pH will equal the pKa. Look out for that always. I'll stop this, let you ponder, get a drink and some food, and then I'll dig into what the pH would be at the equivalence point and how we'd figure that exactly out.